Alright, let's learn about GAN. So GAN stands for Generative Adversarial Network, which basically means it contains two neural networks which works each other in a minimax game, which means uh, it's a zero sum game where the gain of gain of one network is a loss for other network, and those two networks compete with each other in an adversarial manner, but eventually they benefit each other. So though both of them try, since they are fighting with each other, they will grow strong over time, and that helps essentially the overall network, and the network becomes better at generating synthetic images which looks realistic, which looks very close to realistic images. So the two networks are, one is a generator, which is basically generating, let's take an example of a painting. The generator is like an artist which is generating a painting from the random noise, right? And the discriminator is like an art inspector, which is like taking the painting which is generated by the generator and try to differentiate on whether it's a real image or a fake image. Okay, so discriminator is nothing but just a simple image classifier to indicate whether it's a real image or a fake image, and generator is a network that generates the fake images. Okay, over time the generator gets better at generating fake images very close to the real images, and discriminator gets better at differentiating between real image and the fake image. Okay, and in the end we train the network in such a way that both become better at each other, and at the end when the network reaches an optimal condition, that time we stop the training, and then generator can just start generating images on the random noise every time you do the prediction from that. So this network was designed by Ian Goodfellow in 2014. He later joined Apple, and he has been working for Apple since then, and this has become very popular after Ian Goodfellow unveiled it in 2014. Okay, the goal of GAN is to generate a new image from the random noise, or we could also train the GAN in such a way that it can edit an existing image in a really nice way. And when the machine learning, when a deep learned network is trained to do that, it can really do at a scale, right? We can feed him millions of images to edit in a certain way, and the GAN should be able to do it pretty quickly. So we will go through the architecture of the GAN, and then I will also talk about few use cases where GANs are being used. So here is the architecture of GAN network. Let's zero in on two independent pieces of the GAN network, which are namely generator and discriminator. Okay, let's focus on the discriminator first. Okay, so initially a discriminator, as I said earlier, is nothing but an image classifier. Okay, let's say the goal of this particular network is to generate the images of a zebra from a horse. Okay, so first what we do is we independently train a discriminator so that it is able to identify, given a set of images, whether it's a horse or not a horse. Okay, so we feed the discriminator a set of known images along with the labels. For example, here first three images are images of a horse, right? So we will say this is the image of horse. We will label it as is horse equal to 1. Second one also we'll say this is the image of a horse. We'll say is horse equal to 1. Third one is also image of a horse. We'll say horse equal to 1. But the fourth one is not an image of a horse. It's the image of an elephant. So in this particular we will say the image of a elephant, and we'll say is horse equal to 0. and we will feed thousands of such images to our discriminator, and we will train that independently first. Okay, so the discriminator now becomes better at classifying the images whether it's a horse image or not, right? Now that's about discriminator training. Then let's talk about generator. Generator, basically what it does is, it takes initially it just take a random image and tries to generate a fake image. Okay, so this is the fake image that it will generate. So initially the image will be very noisy, right? It will be just a noise. Okay, but then the discriminator will have a next task, whether he has to differentiate between fake image, whether it's a horse or not, right? So initially discriminator will say, since most of the images are fake, it will just output is or equal to 0. Now that feedback, the output of the discriminator will be given back to generator, and generator will say, oh, I tried to generate the image of a horse, but discriminator is saying that it's not a horse. So the generator then tries to update its model to move towards generating the image of a horse, right? So overall network loss, we will train the net generator in such a way that it tries to reduce the error between the fake input and the output of the discriminator. So over a period of time, the generator gets better at generating horse images. Okay, and the discriminator also then we will again train. So we will train in discriminator and generator in batches. For a batch we will train discriminator, and the next batch we will train the generator, right? So the generator gets better at generating the horse images, and discriminator will get better at differentiating between this real input, this real image which is coming from here, and the fake image that is coming here, right? So both try to get better at each other, but eventually what will happen is this generator will get better at generating the image of a zebra, right? Because that's the goal which we have classified it to do. So, and then we can stop the discriminator, and we can stop the training once we start seeing, once the loss reaches to a certain value, and at that point in time we can just remove even discriminator from the network, and all we need to do is just ask generator to give me next set of images. So generator will keep generating a new novel set of zebras which you have never seen. Like, these are not the pictures of zebras that somebody has taken a photograph. The generator has learned from the different set of features from the horses the discriminator gave it, and it has generated a completely new set of zebras from the images. So that's how the GAN network works. So both generator and discriminator works with each other in adversarial fashion by making an overall network a lot better, and that's why this is called a GAN network. Okay, so the goal of the GAN network is to generate synthetic images or to edit an existing image. In this particular case, it is editing a horse image to make a zebra image. Okay, so there are several other applications of GAN which will go into details in the next lecture. But this is how the GAN network works. So the process eventually reaches an equilibrium when the discriminators can no longer distinguish real images from the fake images, right?